So the first way to approach this question would be to draw the structure of water. As stupid and as silly as that may sound, that's what you should do. Okay. So if we draw the structure of water, what do we get?
You get an O with two hydrogens off it. And
what type of solvent is this? Polar or non-polar?
it's polar.
Why is it polar?
Because you've got the positive and negative polarizing.
How do you get the positive and negative?
From the hydrogen and the oxygen.
Ultimately from our oxygen. That's our biggest part. The oxygen being more electronegative than our hydrogen.
Right.
So it's definitely polar.
But I don't remember why though.
How polar is it? Is it protic or aprotic?
Because that's partial positive, so it's got less.
Aprotic.
So what does aprotic mean?
That you have a hydrogen attached to an oxygen.
Okay, so you just have your definition.
Something really.
You have your definition swap. So if a hydrogen is bound to oxygen or nitrogen, it's a protic solvent because oxygen and nitrogen are effectively super electronegative, getting us very, very close to an H+, a proton. Okay, so this solvent, because we have that hydrogen and oxygen, it's polar protic or patic. So the other thing that we'll add to this would be partial charges.
So then
the hydrogen would be positive and our oxygen would be negative, right?
Right.
So what's the question then asked?
How would it affect a nucleophile?
Okay, so what you should then do would be define a nucleophile.
Something that's negative.
What's that?
Something that's negative.
Okay, we can work with that. It's not quite a definition, but that works. A negative species would be a nucleophile.
That's what I understand.
What happens if I bring that negative nucleophile near my protic solvent?
It'll be. Well, it'll react with or interact with the positive hydrogens.
What does that do to the negative?
It lessens it.
Okay. So what happens to the strength of the nucleophile?
It weakens.
It's weaker. Okay. Because of that large partial positive. Okay.
So ultimately, it wouldn't matter then in an SN1 reaction.
So then the next question says, which mechanism is it irrelevant for? Well, we would then write down our SN1 and SN2 reaction conditions, or look it up, okay, and evaluate what things were important. And the only thing we've really told you is the solvent and the nucleophile.
Right.
Okay. Which of those, if we start with the nucleophile, which one needs a strong nucleophile?
SN2.
SN2 needs a good nucleophile. Okay. We don't care about the SN1. So which one is it really going to have an effect on? SN2, because that weakens the nucleophile strength. Okay. So the one it would be irrelevant for would be the SN1. The other option, we can kind of cheat on it. We could look up the solvent. What solvents do you expect for each of those? Do you have that memorized?
The solvents for which one?
For SN1 and SN2? Most people don't have it memorized.
I don't have specific solvents.
The types of solvents?
SN, well, like the polar protic and polar aprotic. So that would be the polar protic and then polar aprotic.
Other way.
Oh, polar aprotic. Yeah,
our SN2 is aprotic. And our SN1, whoops, is I write SN1 again? Our SN1 ends up being polar protic. Why is that important? Well, we go back. Water, we said, was... Why aren't you guys catching me do that?
I was about to say, I was like, why'd you write aprotic as well? Did you already erase it?
Polar protic. Water is polar protic. It's not going to have an effect, right? Because that's exactly the solvent that we would want. Okay. So there's two ways you can approach
What was
that.
the explanation for why it's the nucleophile is weaker?
Why it makes it weaker? So that's looking at our structure for water. We generate a partial positive and partial negative charge. And those are the biggest partial positives and negatives we can get. So that's what's happening with it being a protic. Oh, shit. That's what's happening with it being a protic solvent. Okay. If we take a nucleophile up with a negative, what's that negative going to interact with?
Positive.
The positive. What happens to the size of the negative if it interacts with a positive?
Okay.
It's going to get less negative. It's by definition going to get weaker.